Structure of Atom Part 2. Thomson's Model of an Atom. J. Thomson proposed that an atom possesses a spherical shape in which the positive charge is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Many different names are given to this model, for example, plum pudding, raisin pudding, or watermelon model. This model can be visualized as pudding or watermelon of positive charge with plums or seeds embedded into it. An important feature of this model is that the mass of the atom is assumed to be uniformly distributed over the atom. Limitation. Though this model was able to explain the overall neutrality of the atom, it could not satisfactorily explain the results of scattering experiment carried out by Rutherford. Rutherford's scattering experiment or alpha particle scattering experiment. Rutherford took a very thin foil of gold and bombarded with a fine stream of alpha particles from a radioactive source. A circular screen coated with zinc sulfide was placed around the gold foil to detect the deflected alpha particles. Whenever alpha particles struck the screen, a tiny flash of light was produced. Observation and conclusion. Most of the alpha particles passed through the gold foil undeflected. Hence, it was assumed that most of the space in the atom is empty. A small fraction of the alpha particles was deflected by small angle. Hence, Rutherford assumed that there must be some heavy body at the center which is extremely small, positively charged and occupying a small volume. A very few alpha particles bounced back, that is, they were deflected by 180 degrees. Hence, Rutherford assumed that some of the alpha particles bounced back due to direct collision with that positively charged mass at the center. Rutherford's nuclear atomic model. Rutherford assumed that an atom consists of a tiny, heavy, positively charged nucleus at its center surrounded by a hollow portion called extranuclear part. The electrons in the extranuclear part are revolving around the nucleus in circular paths called orbits. The electrons and nucleus are held together by the electrostatic force of attraction. Drawbacks of Rutherford's atomic model. It could not explain the stability of an atom. According to classical physics, an orbiting electron accelerates, hence radiates energy continuously, and thereby the electron will lose energy continuously and will follow a circular path of decreasing radii. And finally, it will fall into the nucleus and the structure would collapse. This behavior is never observed. It does not give any information about how the electrons are distributed around the nucleus and what are the energies of these electrons. Neutrons had not been discovered in this model. Bohr's atomic model. According to Bohr, an electron in the atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits or shells or energy levels. As long as electron remains in a particular orbit, it does not lose or gain energy and its energy remains constant. When transition occurs between two stationary states that differ in energy, the frequency of radiation absorbed or emitted can be calculated by the formula E is equal to h nu, where h is Planck's constant and nu is frequency of radiation. An electron can move only in those orbits for which its angular momentum is an integral multiple of h by 2 pi, which is given as mvr is equal to n into h by 2 pi. Here n is an integer which can be 1, 2, 3, etc. H is Planck's constant, m is the mass of the electron, v is the velocity, and r is the radius of the circular path. Limitations of Bohr's model. Fails to explain the spectrum in atoms containing more than one electron. It fails to account for the finer details of the hydrogen spectrum. It was unable to explain Zeeman effect, that is, splitting of spectral line in the presence of magnetic field. It was unable to explain Stark effect, that is, splitting of spectral line in the presence of electric field. It could not explain the ability of atoms to form molecules by chemical bonds.